Hi guys, I'm Ashish and you're watching me on Medicare India. So guys, today is ninth lecture of the lecture series based on the AIIMS PhD entrance, basically aptitude part, where I'm going to cover the full biostatistics, maths, English, aptitude, biochemistry, cell bio and mol bio, basically basics part, and all I'm going to cover in the full lecture series of 13 lectures. So this is the ninth lecture and it will be the last lecture of the biostatistics, and it is on biostatistical analysis. So guys, here we are going to discuss all the important parts, basically fundamental errors, sensitivity, specificity, everything I'm going to cover here, and I'll give you a list, a very important list, which is of very importance for the examination point of view, and it will be a summary of all the tests. I mean, what type of test you are going to use when. Means suppose if you are given a data, then what type of test you are going to basically use. So this kind of thing I'm going to provide you in the last slide. And so let's continue guys. Okay, so first of all, before starting the kind of fundamental analysis part, we are going to cover the correlation and regression. Correlation means kind of similarity between the two data. So this is a kind of similarity establishment between two or more than two data. Okay guys, so this is very important to study about the correlation and regression. So they both are the similar term, basically they both want to establish the relationship between the data. So guys, relationship between two data groups can be determined by correlation and regression coefficient depending on the data type, which data type you have actually. So correlation is what? Correlation is a linear relationship between two data. If correlation coefficient equal to 0, then there will be no relation. If correlation coefficient is like -1, then you have the complete correlation with the negative relationship. Okay, and when it has like +1 value, then it will be having the kind of positive relation. Positive relation means if you can see two arrows here. Okay, so in -1 what happens? If one variable is going to increase, then another will decrease. Okay, and when the +1 is there, then both the like kind of data have the same like kind of pattern. If one is going to increase, then another will also increase. If one is going to decrease, then another one also decrease. So this kind of similarity is there with the -1 and +1 value of the correlation coefficient, and it is basically represented by the scatter plot. You all have like kind of seen the scatter plot with the dotted kind of thing, where you are going to draw by joining all the dots. Okay, so then you are finding the basic relationship between the scattered data. What kind of pattern is there with the data points. Okay, so guys, regression is an outcome based, and it is for binary, ordinal and nominal all the data. For binary data, it is of logistic regression is used. Okay, see, this is very important guys, please remember, logistic regression is used for the binary data. Sometimes this is asked. So don't go in detail about the regression, because correlation is important, regression is not much of importance. So guys, while discussing, or you can say analyzing, you are having the two kind of data, basically the categorical data and the continuous data. Categorical data means the descriptive data, where like kind of suppose if I have given you the kind of disease like severity, then you will say mild, moderate and severe, then the extremely severe. This kind is the categorical data. When suppose I am going to find out the like height of the people, then it will be 172 centimeter, 173 centimeter. These kind of things are having the continuous kind of data, where you are having the numerical value. So when you are going to find out the relationship between the categorical versus continuous, first one, then what type of test you are going to use, that we will discuss later. But when you are going to like relate between the continuous and continuous data, then the correlation is used. Okay, so please remember this. Categorical versus categorical is used by the chi-square test and the Fischer test. Okay, please remember this actually box which is shaded is very important guys, very important. Okay, the first one, categorical versus continuous, I am going to cover in the latter part, last part basically. Okay, so don't mind about it. So guys, chi-square test is used where the data values are more than 5. You can see here 30, 20, 15, 20, all are more than 5. Okay, if the like kind of thing is 20, 20, 40, 30, 70, 80 plus 85. In 85, no one is lesser than the 20%. Okay, so this kind of thing you are going to use the chi-square. 20% or value less than 5. When 20% say come or less than 5 data is there, then you are going to use the Fischer test, Fischer exact test. Okay, so guys, in this way you can remember the exact means less. Okay, less means less than 5%, less than 5 value, or 20, less than 20% shell value. Okay, so here you can see 2 is basically about 2.5% of the data. Okay, so this is very important, guys. Please remember it when Fischer and when chi-square test is used. So let's go ahead with the fundamental errors. Basically what happens when you are having a data, then you are having a kind of instrumentation kind of errors, or hands-on errors, handling errors basically. Then these kind of errors becomes very important in analyzing data. This is basically the hindrance. So what happens, there are two kinds of errors. First one is the type 1 error. It is also called the alpha, as I have said in the previous class, the significant level, or p-value basically. Okay, so p-value, all you have heard about it. It is set as 0.05%. So 5% is acceptable. 0.05 means 5%. 5 proportion of 100, it is 5%. Okay, so this is very important, guys. It represents the chance that a researcher concludes that two groups differ when in reality they do not. In other words, you can say that this is a false positive conclusion. Okay, so what you have done, you have said that this data is false, or this value is false, when it was true. It was actually true, but you have told that this is false. So this is type 1 error. Okay, so type 2 error is the chance of false negative conclusion, and it is also called the type 2 error, or beta. Beta is conventionally set as 0.20%. 0.20 or 20%. Okay, so the power is the complement of beta. 1 minus beta equal to power. Very important. Please remember, when I am saying very important, it is really very important. Okay, so this means that power is 0.80% or 80% when beta is 0.20. So guys, it is very important. What power has the value of 80%, and alpha has the value of 5%, and beta has the value of 20%. This is the conventional, you can say, the values. Okay, so what happens in type 2 error? Type 2 error has like kind of data was false, but you have claimed it true. Okay, so this is type 2 error. So gold standard type 1 and type 2 errors equal to 0. So what happens if suppose in a technique we are saying that this technique is gold standard for the evaluation of something, then it will be having the least type 1 error and type 2 error, and that is equal to 0. So no type 1 error, no type 2 errors. Okay, so this is basically about the fundamental errors. Ability of the test. So guys, ability means the capacity of the test. So sensitivity equal to strength of true positive tests. So we will go ahead and learn about all these things in the detail. So specificity is the strength of true negative tests. True negative means negative out of all the negative. Positive means positive out of all the positive. Okay, so type 1 error, mistaken rejection of null hypothesis. So this is false positive. So what happened here? Mistaken rejection of null hypothesis. Null hypothesis was true, but you have rejected it. So the converse is type 2 error. Mistaken acceptance of null hypothesis. Null hypothesis was false, but you have accepted it. So this is basically the terminologies, or you can say the sentence which can be used in the examination for your evaluation kind of thing. Okay guys, and sometimes what happens in the like kind of interview also, they ask about all these things: sensitivity, specificity, type 1 error, type 2. These becomes very important and hot topic for the like kind of interview part. Okay, so please remember it. So guys, this is inverted L diagram. Basically this L type diagram is the main thing to understand, and this L diagram was basically invented by me only. Okay, so that key I can make you clear all the things. Error and ability test. Ability of the tests. Okay, so this L diagram basically I have given this concept of L diagram, and I have basically invented, not in like kind of in a legal way, but I have just to elaborate and make you understand all the things. Okay guys, so in the x-axis there is gold standard test, means the test which is very kind of very adequate and very proper test. You can say gold is mean type 1, type 2 error was 0. Okay, and this is hypothesized test, which test you are going to do in the lab, or you can say the experiment which you are doing. So A, B, C and D, these are the values of the data. Means suppose is positive in your experiment, and positive in the gold standard was A. Positive in your experiment, but negative in the gold standard was B. Negative in the experiment means you have found it negative in your experiment, but it was really the positive in the gold standard, then it was C. And you have found it negative and it was negative in the gold standard technique, then it was D. I think you all have understood about it, because I have told in very layman language. Okay, suppose if you are establishing an experiment and you have a kind of technique that you are going to use in your like thesis work or project, then what happens, that technique and the gold standard of that like kind of analysis. Okay, analysis means there is another technique which is very important, very kind of precise for that analysis, or you can say the experiment. So that in that what happened, the positive, what happened here, there was the type 1 error equal to 0, type 2 error equal to 0. So basically what happened, error was 0. So the gold standard means the positive is the positive and negative is the negative. All positive are positive, all negative are negative. But in the experiment, when you are going to compare with the gold standard, then what happens, the positive in your experiment is positive in your gold standard, then it is A. And what happened, you have type 1 error in the experimental kind of thing that you are doing in the lab. So what happens, the negative will be, some negative will be positive, some positive will be negative. So understand in this way. Okay, so the sum of all the experimental positive is TT positive, sum of all the experimental negative is TT negative, and sum of all the gold standard positive is TG positive, and sum of all the gold standard negative is TG negative. So A is basically specificity of the test. Okay, A is basically what, specificity of the test, means all the positive that you have found in the experiment. Okay, so A is basically for deciding the sensitivity of the test, and sensitivity of the test. Okay, so B is basically type 2 error, chances of false negative. C is here the type 1 error, chances of false positive, and D is here the specificity of the test. So we will actually elaborate in the next slide. So just kind of thing you can remember it here only. Okay, so sensitivity equal to A by TG positive. It means that you have got the positive out of all the gold standard positive. That is sensitivity. Specificity again is the, you have found it negative out of all the gold standard negative. Okay, TG negative. So this is what, in your experiment you have found some positive values. Okay, some means most of the positive values, but how much positive out of the gold standard positive is the sensitivity. On the contrary, what happens, specificity is the how much negative you have found, that was basically positive in the gold test, then how much negative out of all the negative in the gold standard, the TG negative. So please remember, these types of questions are asked in the examination in the form of numerical also. Okay guys, so please remember, this is very important slide. Okay, if you have remembered these things, I mean you have understood the concept of these things, that will be very easy, because the basically behind it the scene is the concept. Okay, so concept is very important for this slide. The next thing is the same thing. Okay, same thing, I have given the values to make you understand the things. Okay, so experimental test and the gold standard test. So in the experimental test you have found positive, that was also positive in the gold standard is 40. Experimental test positive and the gold standard was negative, it is 8. So what is 8? Just go ahead, like go here. 8 is the type 2 error. Okay, so here written in the type 2 error equal to 8. Type 1 error is the 16. Type 1 error means that was negative in your experiment, but it was basically positive in the gold standard test. Okay, so the same thing in the experimental was negative and the gold standard was negative is 36. Okay, so this is the values which I have given. So positive predictive value and negative predictive value, guys, very important, I will say these two things many times asked in examinations. Okay, so A by the, you can say this is the opposite of what? Opposite of sensitivity and specificity. So A by TT plus and D by TT minus. In what you have done in the sensitivity and specificity, you have taken them in the overall like gold standard test, but you are here giving the like kind of experimental data, total experimental data. Okay, so total experimental test may how much A, how much was positive, how much was negative in total experimental test is the negative predictive value. Okay, so this is just the opposite of sensitivity and specificity, you can say. So sensitivity here is the 40 by 56 and it is equal to 0.7. Specificity here is the 36 by 44. No need to explain here, you can just add up the things. Okay, just go in the previous slide and just add and find 0.8 as the specificity. Okay, so this is for n equal to 100. So guys, this is very important. Just go and just revise it. Okay, just go in the back slide and then put the values in the formulas, you will get the answer. Okay, so just practicize it. Okay, this is very short video, I mean of 20-25 minutes, and you can go and practicize as much as you can. Okay, so guys, summarizing all the things, what happened? Alpha is type 1 error and it is also known as p-value or significance level. Okay, definition is the chance of a false positive result, and it has the confidence value of 0.05 or 0.01, basically 0.05 in all the papers, okay, on the articles. Beta is equal to type 2 error, the chance of false negative like results, and it has a value of 0.20 or 0.10 depending on the experiment. So par is 1 minus beta, complementary, you can say, the chance of finding a statistically significant difference between the groups when the difference exists in reality. Okay, so this has the conventional value of 0.80 or 0.90 depending on the experiment. So minimal clinically relevant difference, that is the MCRD, basically synonym is MCRD. So this MCRD is the minimal difference between the groups that a researcher considers clinically relevant, means how much difference is acceptable. Okay, so this is basically found out by evaluating all the papers. While reviewing of literature, you will find that this much difference is acceptable in all the data. Suppose if you are having kind of BP estimation or recording, you can say then how much difference in the BP can be acceptable is the MCRD, minimal clinically relevant difference. Okay, so this is basically, you can say, the important part. It becomes the part of the deviations basically, which we have studied earlier. So variance is the standard, is not the synonym is written like kind of thing, but it is basically what you all have learned. It is the square of standard deviation, variance. So guys, variance is evaluated from the standard deviation, and it is the variability of the outcome measures. Okay, in the case of continuous outcome basically, so it is written for the standard deviation. Okay, so multiplier for alpha 0.05 value is the 1.96. it is basically used for the sample size calculation, which we have learnt in the like kind of first lecture of the biostatistics. That was, it's basically the 4th or 5th lecture of the series. Okay, so guys, this is the conventional multiplier for all the things. Like alpha, it is given for 0.05 and 0.01. so for beta 0.20, 0.10, 0.05, 0.01, all the things, all the multipliers are given. These are basically used everywhere while calculating the sample size basically. So no need to remember these conventional values basically, just remember all the things, the component which is given, and the, I mean, key upper table you can remember. You must remember the upper table. This is all the crux of the lecture, and this is the second crux of the lecture. So what happened, suppose here in the very first slide, if you will go here, then you can see that the like categorical versus continuous correlation is very important. So this becomes here important. So what happens if you have continuous data, and it is basically what the parametric. When the continuous data is parametric, two continuous data you have and it is parametric, then what happens, you can use the t-test for two independent groups, and Wilcoxon rank sum test or McNamara test for two independent groups. Two independent groups means they do not have any kind of relations and they do not have kind of follow-up studies with them. Okay, so they are very like kind of different from each other, you can say. There is no any kind of relation between your height and your blood endorphin level. So these kind of data, you can understand that they are two independent things. So if it is parametric, then t-test is used, and if it is non-parametric, then Wilcoxon rank sum test or McNamara test is used. For two paired data, means suppose if you are having the two follow-ups, if you are giving some drugs and then you are seeing the effect of endorphins basically in the blood, then what happens, if you have started the like kind of drug today, then the today and the last day, this comparison is basically, if parametric data is that, then you are going to use the paired t-test, and if it is non-parametric, then you are going to use a Wilcoxon signed rank sum test. And how these kind of parametric and non-parametric data is analyzed? It is basically by plotting your data. If you have got the data and you have plotted it, then you will easily see the like kind of bell-shaped curve. If that is bell-shaped curve, you can understand that this is parametric and everything. Okay, so guys, for the more than 2 independent groups, you are going to use the one-way ANOVA for the parametric test and Kruskal-Wallis test, ANOVA for the non-parametric test. Very important, guys. These are very, very, very important, I must say. So please remember it. And the chi-square. Chi-square is basically known as the test of independence also. Sometimes they ask like this, okay, what is test of independence? And they will give you the like kind of all the tests, ANOVA, these things, everything they will give. So there, blindly you can take the kind of chi-square test. Okay, so chi-square test is very important. It is basically known as the test of independence. So repeated measure ANOVA you can use for more than 2 paired groups and more than 2 follow-ups basically. So Fredman ANOVA can be used for non-parametric test, and for correlation test, if it is parametric, then you can use Pearson, Carl Pearson correlation, and the Spearman test can use for the correlation of the non-parametric test. Okay guys, thank you so much for watching the video, and thank you so much for your kind attention. You can connect with me on the social media platform. Please like, share and subscribe my channel. Thank you guys.